In this question, you say wire having resistance 18 ohm is cut into three equal parts. So what I'll do, let's say I take a wire here. I took a wire and I'll make it, so whatever. This is the wire and its resistance is given how much? It's 18 ohm is the resistance of this whole wire. Say I take R and it's given as 18 ohm of this wire, say AB I take. Now it is cut into three equal parts. So let's say if I cut into three equal parts, right? I'm cutting them into three equal parts, right? I cut it. Wait a second. This is 1, 2, 3 equal part. And I name this, let's say as ACD, right? So the whatever the length, we don't need to name it. We can figure out that the resistance of a wire is directly proportional to the length. So what will be the resistance of this wire? Can I say it will be 1/3 of 18 ohm? One more time. Resistance of a wire is directly proportional to the length. Since each fragments or each part is 1/3 of the original length, then the resistance of each part, each fragments, right, will also be 1/3 of 18. So I say if I take this as R1, so I'll say it will be, that is this portion, I'll say it will be 1/3 of 18, which is 1/3 of 18 is what? 6 ohm. And similarly, if I talk about this to say R2, this is again 1/3 of 18. So 6 ohm. R3, the third piece, will also be of 16 ohm. Now check, what we have to do is to connect these three wires in parallel. So the wires that we have cut, these three fragments, I have to connect them in parallel. So this is the first piece. Let's say this is the first one, the second one, and the third one. And how we have to connect them in parallel? Let's say if I connect them in parallel. All right. And I'll also use a battery. Well, these are not required to be made in the exam. It is just that to understand I'm making it. Now check here. We know these resistors as the resistance of this as say R1, R2 and R3 is how much? So this is 6 ohm. R2 is also of 6 ohm and R3 is also 6 ohm. Now they are connected in parallel. So we will find out the total resistance. Say I use R dash is going to be what? 1 over R1 plus 1 over R2 plus 1 over R3. So 1 over R dash, as you can see, it is 1 by 6 plus 1 by 6 plus 1 by 6. So I'll get what? 1 over R dash is equal to 3 by 6. 1 plus 1 plus 1. On reducing, it comes out to be what? 1 over 2. So R dash comes out to be 2 ohm. So we'll say that after joining them in parallel, the equivalent resistance, if these three are connected in parallel, should be 2 ohm. But if it connected in series, you will get back 18 only, like 6 plus 6 plus 6. More questions from the concept of different combination of resistors. What is given here are there are 5 resistors and we have to find the ammeter reading when the circuit is closed. I'll go for these two resistors first. As you can see that these two resistors over here are connected end to end by using the same method, wiping R2 from here. Wiping R2, you can, R2 current stops to flow in R1. So I'll say these two are connected in series. So we'll find, say the R dash I use as the resistance for this part of the circuit, which is R1 plus R2. So R dash comes out to be 3 plus 3 as 6 ohm. Now, how is this R dash connected with this resistor? say this one, the orange color, right? This one. This is in parallel. One more time, we can figure out that on wiping this part, that is R dash, current continues to flow in R3. So they are connected independently, right? So if I say what is the total resistance across this region, across say this region, across this, that is this much is the red portion shaded, I'll use 1 over R double dash as 1 over R dash plus 1 over R3. Let's calculate it. How much is this? Is 1 by 6 and this is 1 by 3. So it comes out to be, this is 2 by 6. So that means 3 by 6, which is 1 by 2. So R double dash is how much? That's 2 ohm. Now check again that this one, which is I mentioned as, right, this part as R double dash is connected with other registers. So you can see that other registers with other registers, that is this and this. It is connected in parallel, is it, or series? Let's figure out. As I wipe this portion, correct stops to flow in R4 and R5. This is R double dash. If I wipe out R double dash, you can see that the current stops to flow in R4 and R5. So clearly it is connected in series, that is R double dash. So I'll say that the total resistance R will be R double dash plus R4 plus R5. So this is how much? 2 ohm. This is 0.5 plus 0.5. So clearly R we are going to get as 1 plus 2, that is 3 ohm. So what we got is the total current here. Now, why did we get the total resistance? Because we have to find the ammeter reading, and you can see the voltage is given. So using the formula, that is V is equal to IR, I can say I is equal to V over R, and V, which is 3 volt, and R, which is 3 ampere, get cancelled. From these two, we say get I as 1 ampere. So we got the total resistance as, or equivalent resistance as 3 ohm, total voltage as 1 volt given. So we got total current as 1 ampere. Moving to the next. And continue to do my previous video. Here too, I'm going to solve some 15-20 questions from this chapter, electricity. Now, in the first question here, you can see a figure is given, the diagram, in fact, a circuit diagram is given, and what we are given, the registers, there are 5 registers as we can see, and the resistance of these registers are given, like R1 I can see it's given as 10 ohm. The R2 whose resistance is how much? It is 40 ohm. R3 it is 30. For R4 it is 20, and for R5 it is of 60 ohm. So I just wrote this, and then we have a 12 volt battery, that is the potential difference across this circuit is 12 volt. Now we can see these are registers connected in different arrangement. What we have to calculate is the total resistance. Now first thing that we will do is to figure out the resistor 1 and 2 with respect to each other. How are they connected? We can see that they are connected in parallel. As you can see clearly that these resistors are connected independently with the circuit. That means if I wipe out this, current continues to flow in R2. Similarly, if I wipe out this, it continues to flow in R1. Therefore, these two resistors are connected in series, and we can find out the resistance. Say I use R dash for this whole region, right? I once again mention, for this whole part, I'm using R dash. That is the equivalent resistance of these. So it's going to be R dash here. So 1 over R dash is what? 1 over R1, which is 1 by 10, plus 1 over R2, which is 1 over 40. All right, now then what we'll do, we'll take LCM here, that is 40, 10, 4 times, 41 times. So that is 1 over R dash is equal to 5 over 40. That can be reduced as 1 over 8. So by cross multiplication, we got R dash as 8 ohm. We got R dash as 8 ohm. Now check for the other 3 resistors here. Again, these 3 resistors are connected in parallel. We can use the same concept here. If you put your finger or wipe out any one of them, you can figure out that the current continues to flow in the other 2 resistor, that is R4 and R5. Similarly, if I put my finger over here, cover this, I can see that current flows in the R3 and R5. So that means these 3 resistors are also connected independently, and they are in parallel. Now, if I use the equivalent resistance of these 3 registers, say the total resistance is R double dash, we can calculate using formula as 1 over, say, R3, which is 1 by 30 plus 1 by 20 plus 1 by 60. So this is 1 by R double dash. That comes out to be how much? LCM is what? 60 here. This is 2 times, 3 times, and 1 times. So this is 1 over R double dash comes out to be 6 by 60. 6 by 60, that is 1 by 10. So we can say R double dash by cross multiplication as 10 ohm. So this we got as 10 ohm. Now check that how are these 2 resistors, that is this together and this together, are connected. This and this, you can see they are connected end to end. And how do I guess? I wipe out this. You can see the current does not flows in the R double dash. Or say, if I wipe out R double dash, you can see that the current does not flows, or the circuit is not complete. So we can say they are connected in series. And if I have to find out the total resistance here, I'll say R as the total resistance will be equal to R dash plus R double dash. So from here it is 8 plus 10. So it comes out to be 18 ohm. Well, we did the first part, and then what does it say is to calculate the, well, once again, we did the total resistance by adding these two. And finally, what we have to get in the second part is to calculate the total current flowing in the circuit. So here we can apply the Ohm's law, formula derived from Ohm's law as V is equal to IR. So V we know as how much? 12 volt. And I is what we have to get. And the resistance is how much? 18. So I will be how much? 12 divided by 18. On reducing, it is how much? 6 2 times, 6 3 times. So that is 0.66 or 0.67 ampere. So one more time, we had V given here. We had V given here as 12 volt. IR was 10, 18, sorry. Using this relation, we got current as 0.67 ampere. Now let's move to the next question. In the next question, we are given a diagram over here, and let's see what we have to solve in the first part as the total resistance in the arm CE, right, from here. So what you can see that in the arm CE, there are 2 resistors. One is of 2, another of 8 ohm. Very clear that they are connected in series, and for finding out whether they are connected in series or not. Well, one thing is very clear as they are end to end. Moreover, if you wipe out one of the resistor, the current does not goes to the second, that is the other resistor, say of 2 ohm. So let's say if I consider this resistor, say R1, yeah, say this I take as R1, right? And taking this as R2, take this as R3. So what you can see that the first part, the total resistance across CE, and if I use the term R dash here, as you can see that these R1 and R2 are connected in series. Let's keep some space here. So R dash will be R1 plus R2. So R1 is how much? 2 ohm, and R2 is 4. So we can say R dash is how much? 6 ohm. So that should be the answer for the first part. That is, this is 6 ohm. Now in the next part, they say total current, calculate the total current from the battery. So in order to calculate the total current from the battery, this is partially not visible to you, so I'll make it. Okay. So now what we have to find out the total current. So in order to find the total current, we need to find out the total resistance, right? So let's rewrite this again. This was, I took this as R1, this as R2, and this is R3. So as I said, in order to find the total current, we need to find the total potential difference, which is given, but then we have to calculate the total resistance, or say equivalent resistance. Now let's consider these two. As you can see that resistance across CE is 6 ohm and resistance across AB is again 6 ohm. And how are these two connected? You need to see that these CE and AB are connected independently. Therefore, they are connected in parallel. You can also figure out by wiping one of them. You see that on wiping AB, the current continues to flow on the CE. And likewise, if I wipe out the CE, current continues to flow. So we'll say that the total resistance, say I use the term R here, the total resistance R will be equal to 1 over R dash, which is the equivalent resistance across CE, plus 1 over R3. So if I calculate what I'm going to get, 1 over R dash. R dash is 6 from here, and this is already given 6. So it will give you how much? 1 by 6, 1 plus 1 by 6 is 2 by 6. On reducing, we are getting R as 3 ohm. Now, why did we calculate this? As I said in the beginning, we have to find total current. For this, we need total resistance. So now you see here from this, what can say that applying this formula that V is equal to IR, I can say I is equal to V over R, and I is V, which is 3 from here, and R, which is 3. So we get this as I is equal to 1 ampere. So we got the total current, and that is the answer for the second part here. That is, this is equal to 1 ampere. Now we have one more part here. And what is it? Is this current across AB and CE. Okay. So across AB, and across CE, you can see that here these resistors are connected in parallel. So in parallel, the current does not remain same, it varies. So let's say I use I1, right? So I is equal to, from here, right? I is equal to V over R, then I1 should be what? I1 should be V over R1. So I1 is equal to V, which is 3 volt, as you can see from here, and R1. What is R1? R1 here is, okay, there can be confusion with R1. So let's see. It's I across CE, across CE. What I should use? Say I dash is equal to V over R dash, because this is R dash. So if I place these values, say I dash V, which is 3 volt, that divided by R, which is 6. So it comes out to be half ampere, or 0.5 5 ampere. Now applying the same thing, I can get I2, or say I double dash, that is current across this. So it's clearly same values, 3 over 6. So we'll give you half, that is 0.5 ampere. So across AB it is 0.5, and across CE again it is 0.5 ampere. That's how we'll get the answer for this question. So we had the third part. In third part, these are the values for the answer. See, in the next question, we have to find the current drawn from the battery by a network of 4 resistors. That's given in the diagram, and we can see that the battery, the source here is of 3 volt. So first thing that you will figure out, what I'm going to do is to name these resistors as, say, R1, R2, and R3. I say this is R1, take this as R2, this being R3, and this being R4. Now you need to see that these 3 resistors are connected end to end, right? These are connected end to end, so clearly they are in series. You can also judge this by wiping out any one of them. Like, say, if I wipe out R2, I can see that current stops to flow in R1 and R3. Or maybe if I wipe out or cover with this finger, let's say R1, the current stops to flow in R2 and R3. So one thing is now clear, that here the resistors which are connected in series are these 3. Let me once again show you that the resistors here, where's that gone? Yeah, it's here. These 3 resistors are connected in series, right? These 3 resistors are connected in series. So if I have to find out the resistance across this, so let's say if I use R dash here, will be equal to R1 plus R2 plus R3. So R dash comes out to be 10 plus 10 plus 10. So R dash is how much? It is 30 ohm. Now let's figure out about this R4. R4, as you can see, it is independently connected. By that I mean to say that if I remove these 3 resistors, or if they stops working, current continues to flow in R4. So it is independently connected with R dash. So we can say that it is parallel. So if I have to get the value, say 1 over R, I should say it is equal to 1 over R dash plus 1 over R4. This is R4. So now calculating this by placing the value, R dash, as you can see, is of 30 ohm plus 1 over 10. So it comes out to be how much? LCM is 30. This is 1 times and this is 3 times. So now if I continue writing, so 1 over R is equal to 4 over 30, can be reduced as 2 by 15, or I can say R by reciprocating is 15 by 2, which is 7.5 ohm. So our total resistance in the circuit is of 7.5 ohm. 7.5 ohm. Now let's figure out that we know that the potential difference is this. Using the formula derived from Ohm's law, which is V is equal to IR, I can say that we have to calculate the current, right? That's why I'm calculating I here. I is equal to V over R. So V, which is 3 divided by R, which is 7.5. I can remove the decimal, write it like this, 6 times. Or let's say by 10 by 3, it is 10 times is all same. And this is 25 times. 5 2 times 5 times. So I comes out to be how much? 0.4 ampere. Right. Should I cross check it? Let me check it once again. This was 30 over 75, right? Yeah, so 30 divided by 75 should come as 0.4 ampere. So the final answer for this, we'll see that it is equal to 0.4 ampere. Okay, that's done. Let's move to the next. In the next question, it says find the current flowing through the following circuit. Now, first of all, we need to see the arrangement of these circuit. What I'll do, I'll first consider these two, or let's say if I write these or name these register, I name this as, I'll start from below. Let's say R1, this is R1. Say this is R1, this being R2, say R3, R4, and this being R5. First, I'll go for these two registers. You can figure out that they are connected in series end to end. And the reason, as usual, I'll say that on wiping out any one of them, the current stops to flow in the other register. So first, I'll find the equivalent resistance of these two registers, and I'll name this as R dash. So I can say that R dash comes out to be, I'll make some space here. R dash comes out to be R1 plus R2. So R dash is 1 plus 2. No, it's 1 plus 3. So R dash is how much? 4 ohm. Okay, now let's move slowly. Now let's consider this, like say, now I'm talking about the resistance across this. So you can see from here, this is R dash and this is R4. They are connected independently. As you can see that on wiping, say R4, current continues to flow in R dash, or conversely, that is other is also true. So now I'll say that if I use R double dash for finding the resistance across this shaded portion, what you can see here that I'm using R double dash for this. So this R double dash will be what? Sorry, they are connected in parallel. So I should say R 1 over R double dash is 1 over R dash, that is this part, plus 1 over R4, that is this. So now let's place the value here. This is how much? 4 ohm. And R4 is how much? 6. So this is 1 over R double dash comes out to be 24. This is 4 6 times and 6 4 times. Or I can take LCM as 12 to reduce the working. This is 4 3 times and 6 2 times. So 1 over R double dash by cross multiplication, I can straight away say it is 12 over 5 ohm. Right. So in the beginning, we first find out R dash, then we calculated R double dash. Now check here. We are talking about R double dash as this part, coloring, say, or painting what? Green. Now check for the other two registers. The other two registers, that is this and this, are connected in series. You can see they are connected end to end. So if I have to find the total resistance, say if I use R as the total resistance, it will be what? Say R3 plus R double dash plus R5. Now let's add these. It comes out to be what? 3.6 plus this is how much? This is 12 divided by 5, right? So that is 12 divided by should give you 2.4. So this is 2.4 from here. And R5 is 3. So R is equal to this is how much? 369. Should be 9 ohm. So first I did 3.6 plus 2.4. So 3.6 plus 2.4 is what? 6. 6 plus 3 is 9 ohm. Now check what we had to calculate is the current flowing this. So V is equal to IR. I can say therefore I is equal to what? V over R. From the figure, how much is V? 4.5. 4.5 divided by 9. 4.5 is half of 9. So I can cancel this. So I is how much? Total current is 1 over 2 ampere, or I can say 0.5 ampere. So this was what we had to get. That is the current which we got this. The potential difference was given 4.5 volt. Now let's move to the next question. Similar to the previous question. Here it says consider the following circuit diagram. As you can see, a circuit diagram is given and there are five resistors, each of 3 ohm. And what we have to find out is the equivalent resistance. Now, as usual, we will be first taking these two resistors. Say this is R2 and R3. We can see that these two resistors are connected end to end. That means they are connected in series. Further, you can check with wiping one of the resistor. You say that the current does not reaches the other one. That means this wiping R3, the current does not reaches R2. So this we get to know that these two are connected in series. So let's first find out the equivalent resistance, right? So equivalent resistance, let's say if I use R dash here as R3 plus R2, right? So R dash comes out to be, they are all of each of 3 ohms. So this is 3 plus 3. So I'll say R dash is 6 ohm. Now, once again, you can check that this R was that it was R dash, which is this one, right? Now, this is R dash. This is R dash, the one I just shaded. Check here. How is this R dash connected with this resistor, say R4? So it is connected in parallel. You can figure out once more time. If you remove this, current continues to flow in R dash, or if I remove this R dash, the current continues to flow in R4. So now we can say, for example, if I say that R double dash is the resistance for this whole part, right? So this is going to be what? As they are connected in parallel. So we can say that 1 over R double dash is equal to 1 over R dash plus 1 over R4, well, this being R4, and this is R dash. Now placing the value here, this is 1 over 6 from here, and this is R4, which is of 3 ohm. So we can say this is 1 by 3. So it should give you what? 1 over R double dash. This is what? Taking LCM. This is 1 time, this is 2 times. So this is 3 by 6, which is 1 by 2. So R double dash by cross multiplication is 2 ohm. Now, here R double dash, as I said, is the equivalent resistance of the one which I am shading, the equivalent resistance for the region shaded. That means this whole region, right? So if this is clear to you, that the equivalent resistance for this. Now check how is this R double dash, this R double dash is connected with the other two resistors. The other two resistors, clearly this is these two resistors. Now you can see that on wiping one of them, on wiping say one of them, you can see that the current stops to flow in the other. And similarly, if I replace this R double dash, what you can see, current stops to flow in R1 and R5. So this is now clear that this R5, this R5, R5 is this R5, R1, and R double dash are connected in series. So we'll now say that the total resistance, which is a equivalent resistance, say R is equal to R double dash plus R1 plus R5. So it should give you how much? R double dash is 2 ohm, R1 is 3, and R5 is also 3 ohm. So it will be 3 plus 3, 6 plus 2, 8. So equivalent resistance or the total resistance of the circuit is 8 ohm.